So continuing with our integration videos, I'm going to throw this one out there. This is the integral of cos x multiplied by sine 2x. Now you may be tempted to use integration by parts, and it's a possibility, but actually it's going to get messy and I don't think you'll probably go anywhere, because the fact that we have sine 2x and cos 1x here is going to cause complications. So what I'm now going to do instead is I'm going to change sine 2x to the identity of 2 sine x cos x from our double angle formulae, and the integral then becomes cos x times cos x, 2 outside, get cos squared x sine x dx. So now everything's being turned into 1x in terms of trig functions, but we've still got a mixture of trig functions. I've got a cos squared in there. So I'd be tempted at this point to change my cos squared to the well-known identity 1 minus sine squared x. And then this will enable us to put everything in our integral in terms of just a one trig function, which can be beneficial. Okay, so we've split it up now. Instead of just the one product integral, we've got two separate integrals. We've got the sine x, which is easy to deal with. However, we've also got sine cubed x, which we have dealt with in a previous video, but I'm going to do that up here separately. So let's just consider the integral of sine cubed x dx independently. Now, this was dealt with in a previous video by using a substitution. Our substitution was somewhat counterintuitively cos x. And the reason I did this is because actually something nice happens when I differentiate. Cos goes to negative sine, and then if I rearrange to get dx on its own, I end up with negative du upon sine x. Now I'm going to substitute this in place of dx, and you'll see something nice happens. The integral then becomes sine cubed x, negative outside, du over sine x, which actually allows us to take our power down by 1. Thus making our integral a little easier. So we've now got the integral of sine squared x du. Notice we've got sine squared x, but we're integrating with respect to u. We need to do something about that. So I'm going to use the relationship between sine squared and cos squared. I know that sine squared x is equivalent to 1 minus cos squared x. And I already know that cos x is u by our substitution, so therefore that's the same as 1 minus u squared. So I can replace sine squared x with this, and the integral becomes negative 1 minus u squared du. I can multiply the negative through before I integrate, so I end up with u squared minus 1 du, and we can integrate that directly. I get a third u cubed minus u. I'm not going to put plus c, I'll worry about that over here. And then I'll put our substitution back in, cos cubed x minus cos x. Okay, so we've dealt with the sine cubed. Now what we need to do is deal with the sine x and multiply everything by 2. So this becomes 2 lots of cos differentiates to negative sine, so I know that that integrates to negative cos. Okay, and I already know that that's minus a third cos cubed x minus cos x. And all I now need to do is multiply everything through by 2. So I end up with negative 2 cos x minus 2/3 cos cubed x, negative, negative, you end up with plus 2 cos x, and conveniently they cancel, so I end up with my integral. I'm just going to call this I, just so I don't have to rewrite the whole thing out again. I becomes equal to negative 2/3 cos cubed x plus c. Okay, so that's nailed that one shut. What I absolutely love about A-level maths is you can always find an easier way. So it depends on what path you go down. Sometimes things become very complicated, and sometimes you find a much better way to do something. And since I've did the first part of this video, I came up with a bit of a brainstorm and thought of a very quick way of doing the integral from this point. So instead of changing cos squared x into something else using an identity, I can simply use a substitution where u is equal to cos x. Now the beauty of this is if I differentiate it, I get negative sine x, and then I'm going to rearrange to get dx on its own, so that becomes negative du upon sine x. And you'll see if I substitute this in place of dx in my integral, it becomes equal to 2, I'll take the negative outside, integral of, now cos squared, since we've got u as cos x, it becomes u squared. You get sine x du upon sine x, and magically our sine x cancel. So we simply have a very straightforward integral of negative 2 u squared du, which basically integrates to 2/3 u cubed. I'll just put plus c in for good measure, and replace u with cos x, negative 2/3 cos cubed x plus c, as before, but with a lot less work. Okay, so little update for you.